Welcome back to Grade 7 Science, Unit number 2, Matter and Materials. This is lesson number 5.2, Water in the Environment. Water is often called a universal solvent because it can dissolve so many materials. We can use water to clean just about anything, even stuff that is inside our bodies. For example, water inside your body carries dissolved food materials and other important materials to different parts of your body. It helps your body get rid of waste. You might want to put the video on pause while I'm finished speaking just to take a close look at this picture. What I find really neat is that the brain consists of 90% water. Our blood, that's 83% water. Even within our bones, bone consists of 22% water. Muscle consists of 75% water. It's like our individual bodies are plant water into themselves. All right, let's move on. Fortunately, most of the planet is water. Unfortunately, 97% of the world's water is not suitable for drinking or other activities because of all of the salt and solutes in the water. Only 1% of the Earth's water is usable, fresh water, but even then it may contain some harmful solvents. The good news is that humans have found ways to make seawater usable for human activities. We can remove the salt and some solvents by leaving the water to evaporate in the sun. This method of separating different parts by heating the solution is known as distillation. Distillation can be explained by another important part of the particle theory. According to the particle theory, when something is heated up, its particles move faster. So when you distill water, you heat up its particles, and the particles move faster. The neat part is, the water particles are moving so fast that they are no longer attracted to the salt particles, and they leave the salt particles behind. On the next screen, I'm going to show you a diagram which shows you exactly how distillation works. So we're going to move, starting on the left side, we're going to move up, and going to work our way across and then down. So step 1, the unclean water is heated up. Next, the water evaporates and becomes a gas. The gas is free of dirt and chemicals. Okay, in steps 3 and 4, the water condenses. And in step 5, the water is going to pass through a filter and is released into a fresh, clean container. So for step 6, you now have pure, safe, drinkable water, free of all the salt and dirt and anything else. Another way of removing the salt from water is desalination. Desalination is used in parts of the world where fresh water is scarce and there's a lot of sunlight. For example, desert areas use desalination plants to produce fresh water. The problem is, desalination can take a long time, and it costs a lot to run a desalination plant. Okay, but it's a similar idea. Take your seawater, you heat it up, so the water evaporates, it condenses, forms a vapor, it goes through a cooling period, and then it comes into a fresh container. That's not fresh water. Distillation is, however, expensive. The least expensive way to purify water is a process called settling. Over time, undissolved materials naturally settle at the bottom of the body of water. The water that is on top is fresh and suitable for use. If settling takes too long, the water can be filtered at a water treatment facility. Okay? So you can basically collect the water in a tank and leave it over time, and the dirt, other materials will go to the bottom, and then you can carefully pour out the fresh water. Of course, there are many materials other than salt which can be found in water. Water that contains a lot of dissolved solids is called hard water, and water that contains few dissolved solids is known as soft water. Hard water is safe to drink and it's perfectly natural. Hard water may not be the best water to use for cleaning your sinks and bathtubs, but it won't kill you. I'm going to actually test you guys on this in tomorrow's lesson. I'm going to see how many of you remember J. Garrick's origin. J. Garrick is the original Flash, introduced all the way back in 1940, and he doesn't have such a cool origin as the current Flash. He wasn't struck by lightning and doused with chemicals. Rather, J. Garrick was a young scientist working in a lab. He accidentally drank some hard water, fell asleep, and when he woke up, he had super speed. Also, breathing in fumes from the hard water that he was experimenting with contributed to his speed. Uh, Trust me, this is not going to happen in real life. Okay, drinking hard water will not make you run faster than the speed of light. But that is another story. Alrighty, folks, on the more separate note, let's end our video with this fill in the blanks activity. So when I finish speaking, you're going to put the video on pause first, read each statement, and then fill in the blank. Okay, and all this was taken from the previous slides in this video. So if you're having a hard time remembering the correct words, it means you need to go back and watch this video at least one more time. And then when you're ready, please put the video on pause. Okay? And I look forward to hearing your responses to these questions, as well as your thoughts on what we've looked at in this video in tomorrow's class. But until we meet again, this concludes today's video.